So we have the MMUKO spin sequence. MMUKO spin sequence. Today's date is the 25th of January 2020, 25th of March. Time now is 1:14 p.m. Just a moment, so you're gonna have Nico's dispute. So you're gonna have a half spin, a half spin, a quarter spin, and you're gonna have a three-quarter spin. And then have let's you have a half spin, quarter spin, three-quarter spins, and yeah, this is so it's the half spin, the quarter spin, and three-quarter spins. I'm trying to formulate it. So you have a half spin, you have a half, a quarter, and three quarters. Now, basically here, I'm going to draw a diagram in block sphere. This is basically the block sphere of the particle. Or the particle, this is the qubit. C for Charlie, U for umbrella, U for bike, I for indigo, T for ton. If you get the split, it's a particle. It's one particle on the split up and move away. And then spin up, and spin down. These are two absolute properties of spin. So if you have soft, you have hard, soft and hard. So this is very important to understand the soft and hard based on the surface of the smoothness. So this basically is a smoothness problem. We call it the smoothness problem because we're trying to determine how things are smooth and we're soft. So we soft go hard. And the type of spins that do this are literally rules that so if you're gonna have a spin of half a quarter of the minute. And I'm taking stuff like this directly. Come on, nobody. Well, so you have quarter, you have a half spin, then a quarter spin, then you would have the plus one plus spin of this. This spin is basically half plus quarter is 6 to 8. They have serious what happened to them? Okay. Yes, no problem here. You have three spins. Only three spins you have a half 1 divided by 2, 0.5 plus 1 divided by 4 plus 1 divided by 4. 1 divided by 4 times 2 to be 1. So you have one full spin. And the goal is today, I'm trying to determine how this works. So my goal is trying to determine how a half spin, a quarter spin, and an 8 spin work to give you 10 minutes of spin. So if I have a softball, and a ball is a constant, if I hold the softball down, I hold the softball, they have a sequence of what is smooth surface. This one is you have two types. We have a tennis ball, and a tennis ball. And I hold the tennis ball down, and tennis ball is have a spin of a half. Something must say they could go tell me what is smoothness, what I feel. And the feeling is as real as me to you, a golf ball or a golf ball or a tennis ball or a table tennis ball, a ping pong ball. Now, one thing to say is that there's two properties. They have a blood representation of the system based on how you interpret stuff. Because MMUKO is F which works kind of the spin sequence. So I don't know what the spin sequence of the state is, but they have different states, and that's going to give you different feelings. It's like the idea of if I have a bullet and the bullet is if I shoot a bullet and I'm racing the bullet and I'm racing the bullet and I'm racing the bullet, I'm racing the bullet. in a car, and the bullet, and I'm driving a car, and I'm racing a car, and I'm driving a car, I'm racing the bullet, and the bullet, and I catch up with the bullet, and bullet, bullet, what would be the measurement of, what would be the properties of my car to the bullet based on aerodynamics, and this knowledge is what I'm going to give you because bullets more aerodynamic than a car, so they have to understand that these traits are what good traits, and we're going to do three things, guys. Traits are behaviors that are defined based on dimensions like gravity. Gravity, you got electron, you got muon, and you got twelve. T for tango, E for alpha, E formula. Now the 12, T for tango, E for alpha, E formula has a dimension of 9.6. Once again, guys, on 9.6 divided by 0.1. The weak force of gravity is 0.1. So, because if you use laptop to measure system of gravity, that was 0.1. Because if the medium is basically Leptonian means electron. If you have some kind of weak force, basically, if you have 9.8, you're measuring with small, no, lepton, no, a spin of a half. And the spin of a half, basically you measure with the graviton, and the graviton is a muon or a lepton or some kind of a with lepton, you measure with a lepton, yes. Now, the lepton is basically a quantum particle, which is a state of the quark. It has no mass, but it has no mass, it needs to measure the result. So you have to have two reads of full right to write to it, and four rights and two reads to measure it. That's what read it. So the goal is to have some drop in the scale of the measurement of the qualitative dimension. So more formally or less formally, one half divided by plus 1/4 is one half, one divided by two plus one divided by two plus one divided by four plus one divided by four. It's one. It's one. It's one. And this is one whole unit of a system. So the one whole unit is what can be defined as the measurement of the frequency soft and hard. And the main principle I'm trying to give you is that when you have a ring boot system, ring booting is like we could be first of a ring booting. You have things in a state of supervision. Everything is a qubit, but when you create a load, there's no errors. It's a corruption-free program. And the status and the system is to take what's soft and hard. Whether you are mission keeper person and the kind of smoothness of a ball is like it's probably the most shear. So if you see something so smooth, are you talking about it being soft and smooth? It will be hard and hard and smooth. Not opposite, not like bumpy. Now, if you have smooth, you have bumpy, and that bumpy would be a golf ball. And growth will be something that you can always work with. So I'm not necessarily computable. So if you have am I spinning up or am I computing up to soft or hard? If I'm computing soft, so let's say it's a half soft, half on divided by two soft. And soft is basically something that's let's define soft as something that's uh, smooth, smooth and round, smooth and round. Smooth and round is soft because if I say smooth and round or smooth and hard, because really I'm doing the model of smooth and hard. A hard surface is soft. A smooth and hard surface is soft. Well, a smooth surface is soft. So if it's half soft, it's half hard. In the point of it's a quarter soft. If it's a quarter soft, it's three quarters. If it's a quarter soft, 1/3, it's three quarters hard. If it's another quarter soft, it's three quarters hard. So you're gonna have the spin take kind of system that is operating one. So it doesn't matter if I'm going if I'm racing a bullet in my car. I have some properties because my vehicle is not aerodynamic as the bullet, and the bullet which is target eventually in a car. So the car example is like what I'm giving you. You can get what I'm saying. So the car example is literally the thing that's giving me power to play because at some kind of interval, time and space, your system can start your system can start to decay naturally based on its properties and strength. Like a chicken having a glider and a flyer. A chipmunk, a glide, a squirrel can glide, a chicken can glide, but they can't fly. The thing I'm giving you is like some kind of squirrels can fly, but they can't can glide. It's kind of like because they are gliding squirrels, and by gliding, they are using the aerodynamic principles to evade some kind of predator or prey, because they're allowed to ride, and I love them to that. That they are beautiful in a way because they are there's something that you need to understand. Like this is hard. You got edge is hard, but it's hard because it has density, it has mass. But if it's soft, that means it's buoyant. It doesn't have mass, so it has mass. But no, the softness of say you should have like something that glides and flies, and but when it's a different dimension, it has different properties because these properties are isotropic. They map onto you have no more properties, so you have not got a full picture of it. So now I'm just starting with this, because I'm trying to have the concept of my micro and for my care, for my people, human system that is that respects the kind of sovereignty of sensory information, based on sensory dimension. So anything of similar sense, when it feels very nice and warm, it's very something you do right. So I have each human rights in the framework of organizations. I have each one just for good measure. So because I'm tripolar, so I just need to say that to you because I'm an adult now. So you may think it's kind of a counterintuitive, but it doesn't say the smooth surface is like depicted by the dimension and the pressure kind of things going to the pressure out of it. But on the storm scale, there's something that really get it to me. And if I can't model my computer can't model it, then I feel kind of like my own philosophy. So based on if you have a part, you have my part, you have one, you have code, you have minus, and if you have two axes of hard and cold, you have a smooth and soft. So you have a minus one, but this is the spin up, spin down problem. So it's a spin problem. It's an operation problem, not a quantum system problem. Like, if you have a spin up, that's the operation. You're saying I'm spinning up. I'm pointing to hot. Okay, but my quantum system I say spin up. So my block space I'm spinning up. If I have the block sphere, if I have a Cuban spectrum, half, half, and half, so then that would be half divided by 2 times 3. I get 0.1. With a half, that means I have 0.9. Still from the whole, insane. So it's kind of a new idea I'm trying to pitch out there, but this is not so really coherent amongst what it was doing. So but because of the point, because it was human rights, and my ability to human, I usually computer. The reason I'm going to try to talk about the drone delivery system too. No, not the drone, not that one. The kind of sensory infrastructure, because it's I'm building classical system with quantum computers unconsistent because we don't have computers yet, and that's the next thing to do. Thank you for watching this video. Thank you. I have to get on my bit on my Namdi. So get on with your Namdi. Get on with your what do you call it? Work on your website. Try to sort those out today.